Alright, we are doing 2021 Scholarship Calculus, question 2a and b. A, if log b to the base of a over b is 5, where a and b are both positive, find the value of this. Note the base of this log is a over b. Okay. Let's see what we have to achieve. So this equals what? Alright, I'm going to rewrite this log b to the power of 1/3 and a to the power of a quarter to the base of a over b, right? So if I split them, because it's times, so I can say log b and one, I will just go one more step then. 1/3 to the base of a over b plus log a to the power of a quarter to the base of a over b, isn't it? And now 1/3 and a quarter can come front. So 1/3 log b to the base of a over b plus a quarter log a to the base of a over b, isn't it? So well, we got this. This is a 5, but we don't know log a to the base of a over b, right? But I'm sure we can find it out from here. That is clue. Let me put it this way. So log b to the base of a over b, I can say that is log b over log a over b. And I can write any matching base. Okay, so I can say log b to the base of a over b over log ab to the base over a over b. Okay, so yeah, that's just like a 1, isn't it? That should be 5. But if I write this again, this is divide. So what is it? I can say log b to the base of a over b divide by, so because it's divide inside, that's a takeaway. So I'd rather write it here. So what I'm saying is equals log b to the base of a over b divide by log a to the base of a over b, take away because divide log b to the base of a over b. That is a 5, isn't it? And we know that that is a 5. So 5 divided by, that's what we want to know. So log a to the base of a over b minus 5 equals 5. So this is simple algebra, isn't it? What is it? Log a to the base of a over b must be 1, right? So what is it? Do you remember? We need to know log a to the base of ab. So it turns out that it's 1, right? So over here, that is a 5 and that is 1, right? That's what it says. Oh, sorry. Minus 5 is 1. So log a is not 1. So that means log a to the base of a over b equals 6, isn't it? Right? So knowing that, I'll just say this. That is 5, and that is 6, right? So what is it? 1/3 times 5, so 5 over 3 plus 6 over 4, which is 3 over 2, which is 10 plus 9. So the answer must be 19 over 6 should be the answer. Alright, that was question A. Now, question B. Question B says that from all the possible pairs of positive rational numbers that add up to 11, find the pair that maximizes the product of the square of the first number and the cube of the second number. You know what rational numbers are, right? So it's like a decimal, can be decimal or fraction, but it's different from irrational. Irrational is endless, and it can't be irrational number is can't be fraction, but rational number can be fraction. So even I say 0.75, it is decimal, but it is still fraction, isn't it? 3/4, right? That's rational number. So examples of irrational number is like a pi, square root of 2, square root of 5, e. Yeah. So say two positive rational numbers is x and y. So x plus y equals 11. That's how you start, right? And then the question is, what you have to maximize is the product of these, not just these. The first number you have to square. Oops. Yep. And then times by product means times, isn't it? And second number, which is y cubed. We don't know what that is, but let's say p. And then we have to maximize. So, well, when you hear maximize straight away, we have to differentiate p, right? So dp over what? Because we have two variables, you can't at this moment. You have to unify, meaning only one variable. So that's why you have this parameter here, x plus y is 11. So say x is easier. Let's define x in terms of y. So x equals 11 minus y. You know why I didn't make y the subject, right? So if I did, then I have to cube. It's much harder than squared, isn't it? So you plug 11 minus y into this. So 11 minus y squared, oops, times y cubed. Now it's one variable. So once we can just do it as a product rule, isn't it? Yeah. So straight, instead of with expand, we know product rule. So why don't we do apply that? So we are finding dpd. Wow, this is not what I want. dy, right? Sorry, this is the, but this program keeps saying it's a delta. So ignore that. So what we have to do is u is 11 minus y squared, and v is y cubed. So u prime is u u prime is what? Inner is negative, so negative, and outer is 2, 11 minus y, right? And b prime is simply 3y squared. So dp dy equals vu prime, which is minus 2y cubed times 11 minus y, plus uv prime, which is 3y squared times 11 minus y squared. Now, I think it's better we organize this. Yeah, I see y squared is common and 11 minus y is common, right? The first term minus 2y, right? And second term plus 3, 11 minus y, yeah? So I have 11y squared minus y cubed, first bracket. And second bracket, I've got minus 2y minus 3y minus 5y, isn't it? And then plus 33. And we expand. So for method, so minus 55y cubed plus, what is 11 times 33? Times 3, 11 times 33. 363. 363 y squared. My plus y 5y to the power of 4 minus 33 y cubed. I'm gonna simplify this. So 5y to the power of 4 first, and then between these two, it's minus 88y cubed, and then plus 363y squared, right? So I can factorize by y squared. So I've got 5y squared minus 88y plus 363. You know that y can't be 0, right? Because it says, the question said two positive irrational numbers. Rational numbers. Positive, I mean. So, yeah, y is not 0. So we have to find the answers from here. Once you find the y, then x is easy because the relationship between x and y is, add up to 11. So this is a perfect time to use a calculator, right? So I'll show you. I'm sure you guys know. Oops. Menu 1. So we go menu equation. So down there, polynomial and degree 2. In the first number, I mean coefficient of x squared, so in this case y squared, 5. And second is minus 88. And third one is 363. 363. And solve. So y is 11, what was it? Or 6.6. If y is 11, x must be 0, right? Add up to 11. So that's not right combination. Both should be positive. So 6.6 is right candidate. Let's see, 11 take away 6.6, which is a 4.4. So when one number is 6.6, the other one is 4.4. Right match, right? Both are rational numbers, positive rational numbers. That should be the answer. If you want to check, the best way is you plug 4.4 into x and 6.6 into y, and see the number, and then try out with some other combination. Say, if you doubt, 4 and 7, so 4 squared times 7 cubed, that kind of try. It wouldn't match it. I picked 6.6 squared. Is it the other way around? 4.4 squared plus a 6.6 cubed. Let's try that. Times, oh, not plus, sorry. It's product, isn't it? Oops. Times 6.6 cubed gives me 5,565.92-ish. What if I go 6.6 squared? Of course, this is bigger, but I'm going to try it out anyway. 6.6 squared times by 4.4 cubed. This is 3,700. Oops, 10.6. So this is the best. Now, as I said earlier, so try this. 4 squared times 7 cubed. I got 5,488. Doesn't reach to this. This should be maximum. Let me just check what the question is asking. Find the pair that maximize the product. Okay, we found a pair, which is a 4.4. So answer is 4.4 and 6.6. All right, I'll see you next time. Bye.